right, so nice to see everyone. It's crazy. This is, what, 2024? I think the first PyTorch DevCon was 2018, so it's really cool to see the history lesson from Peter and the folks this morning. So hopefully you can see the slides. I can barely see them. Hopefully the sun goes down and you can see all. So I'm Joe Spisak. You can't actually read any of these words. I used to work on PyTorch for a long time. I helped with others take it to the foundation and build it, I think, to what it is today, which is something that's pretty amazing. I also, today, currently, I lead the open source efforts for Llama at Meta, and I do a lot of advising and angel work as well, and I've worked in research. So enough about me. Let's talk about Llama. So who's using Llama today? Who's developing Llama? Who's downloaded a model from Hugging Face and prompted it? Okay, lots of hands. Who uses PyTorch to fine tune it? Torchtune? Hell yeah, okay. All near and dear to my heart. We've seen some incredible adoption of Llama. You can see some of the numbers. We have 350 plus million downloads. Every time I bug Omar, it keeps getting higher and higher. We've seen we work with all of the cloud providers, work with a ton of partners, dozens of partners. Hopefully everyone saw the 405B launch from, I guess now, not even 2 months ago. There's been literally millions of downloads. The usage has been doubling, and I think since January to July, we put out a blog post on this, 10x the usage. So we're seeing some really awesome usage of Llama, and obviously we've had this crazy set of releases. You can kind of see who remembers Llama 1, the research only, right? Came out of FAIR. It was actually the team who's now Mistral, and we were working on theorem proving, and I was actually in FAIR at the time. That was pretty incredible, and I think the model actually got leaked onto torrent, which was super fun, and that kind of set off a chain of events, including the Llama 2 release, which was a commercially licensed model, which got incredible adoption as well. And then we started to release and get on this kind of train of releases. We released Code Llama out of FAIR. Gabriel Sinov and the team released that. We also released this thing called Purple Llama, which is near and dear to my heart. Anyone know what Purple Llama is? Hopefully. Red and blue, right? Purple, red teaming, blue teaming. So we started to incorporate safety and system level safety in the Llama, which turned it more into an agentic system and not just this model that we all know and love. And we also released things around cybersecurity. And then, of course, the Llama 3 moment came in April. That was truthfully actually more of a pre-release because the context length was pretty small, with the big bang really coming in July with the 405B. Oh, there we go. That's better. With the 405B back in July, and we released a number of components around it, including another Llama guard, the more cybersecurity components, including a new eval, and a prompt injection filter as well. So we started to really to kind of create this full system, which is really cool. One of the really interesting things about the 405B that we found internally, because we use it obviously in Meta AI and our own applications, is it's become a really great teacher for us to build smaller models with. And so when we did post-training for the 8 and the 70B, we actually took outputs of the 405B and trained on those. And that actually allowed us to improve the models pretty significantly. So while these were the same sizes as the models from April, they were actually significantly better, and we actually were able to leverage our fancy 405B for that. So the key features out of these models were obviously a longer context length at 128K. This has been pretty popular. We added multiple languages, which is easier said than done if you've ever done post-training or gotten involved with building an LLM, the amount of safety and work and validation work and SFT you need to do to make sure that these languages are really solid is quite difficult. Tool use is, who knows what tool use is or is called functions out of LLMs. So what was really interesting is seeing the Grok team, if you know the Grok, the inference cloud team, they actually had a post even within a few hours showing how we were state of the art in tool use, there you go. Okay, I see them right there, which I really love that. There you go. That was really cool, and just to see that. So we really put a lot of effort into zero-shot tool use and actually fine-tuning in even tools like Wolfram and Brave Search and other things. So we were excited to see that the community also saw that. So that was really fun. And then one of the things we did for the 405B is we actually changed the license. So if you and not to get into the weeds, or I'm not a lawyer, but I work with a lot of lawyers, and one of the things we did was actually change the license so you could actually train on the outputs of our models. So if you go to like, say, the terms of service for a lot of models that are out there, it will say like, you are in violation if you use the outputs to improve another model. We basically looked at that and we said, okay, no, let's not do that anymore. Like, let's actually make that a feature, not a bug. And now basically you can use the 405B or any of our models, frankly, from 3.1 onward, to basically improve any model. You can improve I hate to say it, but improve a Mistral model or your own model or whatever it is. You can take the data, and what this has actually done is created this new world of synthetic data generation and distillation, and we worked with a number of partners to actually even deploy net new services like AWS and NVIDIA and others, and it's been really, really popular. And so, PyTorch obviously was a pretty big part of creating Llama. We trained it on 16,000 H100 GPUs. Over months, we used over 15 trillion tokens, actually, to train it. So lots of data, lots of compute, lots of failures in our data center. So we actually, if you look has anyone read the 92-page paper that we published, by the way? It's a really, really good read. So, like, if you're sleepy, or if you want to be sleepy, I guess, no, I'm just kidding. But you should read it, seriously. It's the most detailed paper. The team is a labor of love putting it together. We actually went through all the the faults that we found in training, and I'm actually looking at even trying to open source that data set to show, like, how real and how hard it is to actually train a model at this scale. It's not like you just like throw some PyTorch code at 16,000 like interconnected H100s and like magic happens in a couple months. Like, these models need to be babysat, and GPUs do fail, and they fail quite often, and more than you would think. And so getting that right and getting a model to converge at this level of quality at that scale is actually a really, really difficult problem. And so that required a lot of like collaboration across the company, across the Llama team as well as the PyTorch team, and with all the way down to the infra and managing that. So the results were pretty cool. So again, this is like, from late July. You can see we compared against the state of the art at the time. We did not shy away. We compared against GPT-4, 4.0 at the time, and then Claude Sonnet 3.5, which is, still today are some of the best models. Obviously, 0.1 is super interesting. And at the time, like this model was really amazing, and it's being deployed, and actually really, we were like pleasantly surprised at how reasonable it is actually to serve by folks like Fireworks and others that like even a few dollars per, I think $3 blended per million tokens. We also did human evals, so for those who develop models, like it's really cool to show how you're good on MMLU. It's a kind of a fun reasoning benchmark, but it's getting pretty saturated. Same with like GSMAK and some of these other like grade school math type of benchmarks. But the human evals actually show like how people actually interact with their models and how good they find them, basically. And so we found that for certain models, and again, it's a little bit of preference. So if you go on LMSys or some of these other kind of interactive sites like that, you'll kind of get an idea of how well people like to play with certain models. So we spent a lot of time and spent a lot of money to have humans also interact with our models, and they were quite happy with them. So as I mentioned, like Llama is actually evolving very much to be a system. And so if you go to like our GitHub, so Meta Llama on the GitHub, you'll actually see a number of repos that we're actually building and actually open sourcing tools around agentic development. And so I've actually, I know it's very hard to read, but I've actually enumerated the ones I think you should care about anyway. So number one, like Llama Models is our new site basically for all things Llama. So this is basically the basic inference code. It has the acceptable use policy, the license, model card, like kind of everything that's kind of there for the models, and you'll see me there a lot. We have something called Llama Stack, which I'm going to get into here in a second, and this is basically a standard API for how to build agentic systems and a lot more, and I'll talk more about that in some detail. And you can see like from the little squigglies on the activity on the repos, these are pretty new repos. So we've just kind of open sourced these, even as early as July, and we've seen like pretty good engagement. And then Llama Stack Apps is basically where we have all of our reference apps. So I'll show you an example of that later, but basically these are fully open sourced apps that support things like tool use and RAG and other things. Using the API, there's of course Purple Llama, which has everything from cybersecurity, evals to inference time guardrails for insecure code recognition or prompt injection, filtering, those kind of things. And then Llama recipes. I think Hamid and some of the folks who maintain that repo are here, somewhere around here today. And this is basically your one-stop shop for anything from like how do you fine-tune Llama models, to how do you work with like Llama Index or LangChain or kind of any of the common popular projects in the community. VLLM, TGI. Basically, we have recipes for just about everything. So as I mentioned, like we're moving quickly towards Llama being an agent, and actually even more so, we're moving towards Llama actually being a distro. So I can't use that analogy like in my normal day-to-day because no one knows really what a distro is, but I can here. I think people know, like, it's the difference between like having a Linux kernel and saying like, hey, here's a kernel, versus, hey, here's a distro, right? And upgrade the kernel and the new model, and you get this amazing, developer experience, and you can build things with it. And that's really where Llama is heading, which is pretty exciting. And so you can kind of see like an app here that's running in the background. It's pretty simple. It's like uploading a CSV, and like you're able to inspect it or generate code or visualize things. And you can see like the reference architecture is pretty simple. You have an LLM, you have this executor, you can call shields for safety, you can call tools, but basically it becomes like the LLM becomes kind of this kernel, and things around it become these components that get orchestrated. And I will dive a little bit deeper into that. So here's kind of like the stack. So in true open source fashion, we did an RFC. So we got a lot of engagement, lots of comments. It was, we wanted this to be definitely, more of an open community feel. And that actually, people contributed quite a few great ideas that we incorporated into Llama Stack. And there's pull requests. We've seen pull requests from the Llama team, from Fireworks, from a lot of folks, and it's starting to really become this great community. But you can see, like, at the bottom, you kind of have the hardware itself, you have the model, and then you start to see libraries and things layer on top. So obviously, PyTorch, if you want to fine tune or you want to deploy, there's torchtune and torchchat. There's a CLI and an API that I'll talk about here in a second, all the way up through to kind of your agentic application, which kind of builds on all of these components. So one of the cool things that that we're really happy about, or I'm happy about personally, is we built a CLI. I thought, I've heard so many developers kind of say, like, give me a basic, like, pip install, sort of, like, for playing with, like, Llama models. And it sounds, like, simple, like, from a software perspective, but, like, it's actually quite difficult to do for models. But we built it, and you can basically pip install, this thing called Llama toolchain, or you can use Conda, but I personally like pip. And basically what it does is it gives you like the ability to kind of list out the available models. You can kind of understand the models themselves. It'll tell you like things like the prompt template for them, or the system prompt, or basically any description. Does it support different modalities? Does it support what context length does it support? Those kind of things. So it's really quite handy if you like. Who uses CLIs for development? Like I'm kind of expecting every freaking hand to be up right now, but like, come on. See, really? So people are using GUIs for development? No? Okay, come on. Okay, so yeah. So if you're using a CLI, it's really nice to incorporate into your workflow. And you can obviously, like, as part of this, you can incorporate different parts of the distribution. So if you want to incorporate a Llama Guard shield, for example, you can basically install that. Basically, we call it a distribution, or a different API as part of that distribution, and you can kind of incorporate that into your application. And it's pretty simple to add it, as you can see here. And then basically, a distribution is really just a collection of say, RESTful APIs, and in this case, you can create that distribution and then run it. And basically, this Llama Stack API does all the kind of the orchestration for you. So what we found is like it's quite difficult or quite challenging to kind of stitch these components together, whether I want to stitch together inference or fine tuning or even RAG or some of these other components. This is just a really, really clean way to do that. And so you can kind of go here to, I've snapshotted the repo. You can see some of the folders we have that's already there. So if you want to quantize, for example, there's someone built a component to quantize the model as part of your workflow. But everything from inference to deploying and orchestrating safety guardrails to, we call it memory, but it could be more than just RAG. That's why we kind of use the generalized term there. Evaluation, so if you want to basically in situ in your workflow through CLI start to evaluate for different things and run benchmarks kind of in your workflow, you can do that as well. You can do reward scoring. I mean, it's pretty like, it's going to be pretty full featured in terms of what you're able to do. So a couple of things I will leave you with. One is we have a really great site called, it's now llama.com. So it was llama.meta.com. We just migrated over to llama.com, and you can go there, and we have detailed documentation for, like I said, how to build, how to use Llama with ecosystem projects, how to download it from Meta, from Hugging Face, from Kaggle, how to run it on your Mac, for example, how to use it with, again, things like Code Llama and others, or LangChain, Llama Index and others, and so on. But if you want to kind of use it out of the box, you can see some of the platforms that we support. This was actually the table we used for the 405B launch. So every single one of these checkboxes is a night, a weekend, a lot of blood, sweat, and tears to support the 405B and other models on all these platforms. So whether it's AWS and Bedrock, or Microsoft on Azure, or Scale, or Snowflake, or Grok. We worked really hard with all of our partners to make sure that developers can use these things. One of the things we found is like models of this scale are quite difficult to deploy. Before we quantized the 405B model, you had to use distributed inference, and again, this is like a pretty savvy crowd. So who's actually deployed a model across multiple servers for inference? Yeah, I kind of expected some hands. So, but like not everyone can. You guys are the cool kids. So so we quantized the model. It can run on a single instance, but every one of these partners was ready to go, including probably another couple of dozen. It's been incredible. The community has been really leveraging Llama through all these different partners. So that's it. Thanks so much for your time.